We are continuing our lab session from where we left off at the end of the last video. So there we constructed Q, the matrix which is dimension 36,000 by 49. So let's clearly understand what we are doing here. So we are in a 49 dimensional space where all the points lie, because there are exactly 50 points, so it lies in a 49 dimensional affine space, and I have shifted the origin somewhere on the plane. Say I have shifted it to the very center of the data cloud. In that case, now it's an honest subspace whose dimension is 49, and this matrix Q gives me an orthonormal basis for this subspace. Remember, this subspace is inside R to the power 36,000, so all the vectors in Q are of size 36,000, and we have 49 of them which are unit vectors and perpendicular to each other. So this gives me the basis. So now each of my pictures, so just remember that I have shifted my origin to the mean, so my pictures are no more the x things but the y things. Y's are obtained by subtracting the mean from each of the x's. So after I have shifted the origin to the mean, my new values are the y values. I can place all the y values in terms of linear combination of these 49 vectors. For example, if I take the y vector, say of course y here is the matrix, suppose I take the very first photo. So this one, let's just quickly see what its length is. That is 36,000. So that is photo 1 after I have subtracted the mean. I want to know what is the coefficient of the first ONB vector for this vector. So because these things are all orthonormal, I can very easily get the coefficients by taking dot product. So what I shall do is this, I shall take this and then matrix multiplication Q, the first column. Well, I have done a mistake here. The first row of y with the first column of Q, and that is the coefficient. So the first thing is minus 20.56393 times the first vector in my basis. Similarly, the coefficient of the second vector will be this, and so on. Now instead of doing it separately, I can do it in one single go, that is by taking y, multiply that by q. So I will get all the coefficients for all the photos, and this is what is customarily called the scores. So I say scores equal to this. So scores basically express the original photos in terms of my new coordinate system. And I am trying to see how these scores behave. So the scores contain the same information as my original photos, but then let's look at the size of them. The size is much small. It is just 50 by 49. Each row gives you the coefficient for one particular photo, and there are 49 coefficients. So instead of working with this huge stuff, the same amount of information is stored here. Now our plan is to reduce this 49 further, and that is where this principal component analysis, etc., is going to enter.